This lesson is going to be about the law of sines, which is also known as the sine rule. Now, something to keep in mind is that this can only be used for non-right-angled triangles. So let's say you have some triangle, mystery triangle, you've got to try and figure something out to do with it. Maybe you're trying to find an angle, maybe you're trying to find a side. The first thing you need to ask yourself is it right-angled? So is there a right angle in this triangle? So it's either going to be yes or no. If yes, then you might want to look at using either Pythagoras or SOHCAHTOA to help you find whatever it is that you're trying to find. If it's not a right angled triangle, then you might use the law of sines, also known as the sine rule, or the law of cosines, also known as the cosine rule. The law of sines can be written as sine A over A equals sine B over B equals sine C over C. Or you can flip those over if it suits you to do so, and you can write it as A over sine A equals B over sine B equals C over sine C. So what's that telling us? Well, conventionally when we label a triangle, if we call this angle up here A, this vertex A, then the side that it creates, when that angle splays out and creates a line going along here, we call that little a. If we call this angle down here B, this vertex is B, then the line that it creates splaying out to the other side all the way over here, we call that little b. And the same for C. This angle creates this line over here, so we call that capital C for the angle and little c for the line. And these you could think of as matching sets. So if we know that angle and down here, this angle C and the line that it creates, those two pieces of information are correlated to one another. They kind of have something to do with each other. Because how big or small the angle is, like if that was a much wider angle C, the line opposite it would be much longer, right? And if it was a skinny angle, then the line opposite it would be really short coming out to here. So how fat or thin the angle is determines how long the line is. So they match. Same with big A and little a, that's a matching set. And same with big B and little b, that's a matching set. Now for the law of sines to help us out, we need to know two matching sets. Because if we know B and little b, and one of the two pieces of information that make up A and little a, so for example, say we know the angle but we're trying to find the side, or we know the side and we're trying to find the angle, then when we have two matching sets, there's 4 bits of info in that. There's B over the sine of B, and there's little a over the sine of A. Now if we have 3 of those pieces of information, for example, little b, sine of B, and we don't know little a, that's an unknown, but we know sine of A, for example, then we can work out the rest. So essentially what you need to make the sine rule work for you is to know one complete matching set that is either, C and little c, or A and little a, or B and little b. You need one complete matching set, and then one like half filled out matching set. So one piece of information about somewhere else, and we'll use its corresponding matching set side to figure out the rest. Let me show you what I mean. So here's an example. In this non-right angle triangle, we have a matching set here of 95 degrees and 10 centimeters. And we have a matching set here with 35 degrees and our unknown, which is this side along here. Now I could choose to write sine A over A equals sine B over B, or I could choose to write A over sine A equals B over sine B. The way I'm going to choose which way to write it is I'm going to put my unknown on the top of the equation. I put it on the numerator because it just means you have less algebra to do later on. So my unknown is x, and that's a side. I'm going to put that here, and it's going to be over the sine of its matching partner. Now its matching partner is 35 degrees, so it's over sine of 35. Now the corresponding piece of information that I'm going to use, this other matching set that I have, I just need to put them in the same order. So I have sides over angles. So I'm going to put the side, 10, over sine of the angle, which is 95. And now to get the x by itself, I'm going to times the sine 35 over to the other side of the equals. I have x equals 10 divided by sine of 95 times sine of 35. Enter that into your calculator and you get x equals 5.76 centimeters. Now what would happen if they hadn't given us this piece of information down here, this 35? Let's say that we were given this one instead, which is 50 degrees. Now, can we use the sine rule? We still have our matching set here, which is going to help us out, but now we don't know what's opposite the x, so that's a bit of a problem. But remember how all the angles in a triangle add up to 180 degrees? There isn't much maths that we have to do before we can figure out what this angle is. All we need to do is 180 minus 95 minus 50, and we get an answer of 35 degrees. And then we can use this matching pair to do the sine rule. So if you don't see a matching pair straight off the bat, just have another quick look and see if you can work it out easily. What if for this question they had told us that this was 5.76 centimeters, but they had asked us to find what this angle was down here? This was an unknown angle, theta. We'd go about this in much the same way, it's just we'd be flipping our sine rule the way we write it out. So we're going to use this matching piece of information here. This matching set will help us out, and this is our matching set that includes an unknown. Now I'm going to write the unknown on the top, so I'm going to have sine of theta, that unknown, divided by its side, which is 5.76, and that's going to be equal to the other matching set. Now this time I have angles on the top and sides on the bottom, so I'm going to have sine of 95, because we want the sine angle both on the top or both on the bottom. That's divided by 10. Now, to get this 5.76 over to the other side, I'm going to multiply it over there. So I end up with sine theta equals sine of 95 divided by 10 times 5.76. Now, to undo the sine business over here, basically what I'm going to do, the inverse of that operation, is to take the inverse sine. So theta equals the inverse sine, which on your calculator looks like sine to the negative 1 of all of this information. So when I work this out on the calculator, that gives me 0.573. And now what I'm going to do is take the inverse sine. I'm going to hit sine to the negative 1 of that 0.573. And what do you know? I end up with theta equals 35 degrees. So in this example here, I have a couple of matching sets, but they're not that obvious. First of all, I have 9 and 30 degrees. They match. But then the A over here is going to correspond to that angle, and the 15 over here is going to correspond to that angle. So as yet, I only have one matching set. So I can't work out A yet because I don't know what the angle that matches it is. But what I can work out is this angle up here because I have 15 corresponding with it. So let's use sine of 30 over 9. And that is going to be equivalent to this other matching set, which is sine of, goodness knows, we don't know yet, let's call it theta, over 15. So how do we work this out? We times the 15 over to that side to get rid of it. We have sine 30 over 9 times 15 equals sine of theta is 0.8333. Now to get rid of the sine on that operation, to kind of do the inverse operation and get sine over to the other side, we take the inverse sine. So on your calculator that looks like sine to the negative 1 of 0.8333, which is 56 degrees. Now that I know that, I can work out what this last remaining angle down here must be, because all of the angles in a triangle add up to 180. So if I have 180 minus 30 minus 56, I have whatever is left over as this angle. So that's 94. Now I have a matching set with my mystery unknown. A, I have its corresponding angle. So I can use 56 and 15, or I can use 9 and 30 as my other matching set. Let's just use 9 and 30 for now. 9 over sine of 30 is equal to A over the sine of 94. I can just times that sine 94 over to the other side to get rid of it, and I have 9 over sine of 30 times sine of 94 will give me A, which is 17.9, so rounding up I get 18.